Hey all, welcome to Word Problems with Whole Numbers. With me, your host today, Brian. You ready?
Hey everybody, welcome to Whole Numbers, Word Problems on the T6 math course with me, Brian. So let's jump right in. Today, our goals. We will be able to solve multi-step word problems involving whole numbers. Keyword is multiple step. A lot of the word problems we're going to go through are going to be more than one step, so being able to break down those word problems into smaller pieces is going to be so important today. Our key vocabulary of one is a whole number, numbers not containing any fractional pieces. So that just means any number like 45, 9, 3,817, or the phone number of anybody that you know. I actually don't know if this is a phone number. Please do not try it. But any whole number, no pieces. All right, 2, keywords or phrases that we look for. Those are words or phrases that hint at what operations should be done. Now, this might be words like difference, which could imply that it's subtraction. Sum. Total. Now, total is a tricky one because it could go for multiples, so you may need another keyword to go with total. If you see things like each group, words like split may give you an idea of what operation to use. Each group could be division, it could be multiplication. Splitting into equal groups would be division. So just giving you insight as to what the problem could be. Sometimes people rely too much on keywords and phrases. Really try to visualize what is happening in the problem. An operation, that just refers to the use of addition, subtraction, multiplication, or division. So if you hear me say the word operation or what operation are you going to use, we're looking not at doing surgery, but we're looking at addition, subtraction, multiplication, or division. So if we're going to tackle word problems, this is the largest question I ever get all the time. In my 11 years of teaching, everyone was always worried about word problems, always thinking, these are going to make me nervous. I can't solve them. I can't tell you a way to tackle every single word problem of add these or subtract here, but I can give you a really solid method of how to interpret what it's saying without overwhelming yourself. First thing to do, just read the whole problem first. This way you just get a good idea of what the situation is, see if you can pick up on anything, but you at least know everything that's included in that one problem. Second, go one sentence at a time. Just read a sentence. See if you can create something from the sentence. For example, if you had something that says like, John goes to the store. Cool, that's awesome that John went to the store, but that is nothing that I can do mathematical. But if it said, John bought 4 pairs of pants for $20 each, that gives me 4 times 20, so far I can figure out he spent $80. We're going to draw pictures and you can visualize the scenario. Now, this is always a great way to see what's happening. The way or the reason I tell you why to draw pictures or to visualize and write these things down is that oftentimes we try to keep too much information in our brains and we forget what numbers we are using, where they came from, or where we're going. So having some sort of picture or visual to keep track of where you're going is really important as well. You should also be thinking, what can I figure out? Should I be ending up with a larger number or a smaller number? Which operations in this case are going to help me get a larger number? Which operations might help me get a smaller number? That'll help you narrow down how to tackle the problems themselves. And use labels to remember what you found. This is so important just to keep your own brain ready to figure out what's next. So if you did something like, I'm going to use that example about John before. We said he bought 4 pairs of pants at $20 each. He spent $80. Just a quick label, something that lets you know exactly where this is. So that if you ever are in your problem and you say, why did I do 4 times 20? Oh, okay, that gave me the total amount he spent on pants. Something along those lines to just help you out. Think, did I answer the question? So often people will do a problem, just like what John said before. He spent $80 on pants, they'll put $80 in and they'll go. These tests will always try to trick you by thinking that you might have finished early, or they'll think of common mistakes you may have made and put those in the answer choices. I do the same thing. Done it for years. It's a really good indicator if someone actually understands the problem. So you have to read the question again. Did you answer it? Just double check. Takes 2 seconds and is totally worth it in the end. Now, why do we do this? So the majority of mathematical problems in life are not going to be handed to you in a solvable way. They're not going to say, you have to add 4 plus 7 to get 11 for this that you're working on. So you have to be able to interpret these situations and figure out the best way to approach and solve those scenarios. All right, it is time to jump into our sample problems, our sample questions. As always, see if you can read the question, try it on your own, pause the video, then see if your answer is right or not. This is going to be the best way for you to figure out if you understand it. All right, sample question number 1. The nursing station received 36 boxes of Band-Aids containing 45 Band-Aids in each box. How many Band-Aids did the nursing station receive? So again, we're going to go sentence by sentence. So if we look at the first one, the nursing station received 36 boxes of Band-Aids containing 45 Band-Aids in each box. So I'm going to visualize. I see each box, and there are 36 boxes, and I know in each of those boxes there's 45 Band-Aids. So the way that I visualize this, and some of us may be more visual than others, if I have, that's going to be hard for you to look at. So if I have this here, I know that the first box has 45 Band-Aids. The second box is going to have 45 Band-Aids. The third box is going to have 45 Band-Aids. All the way to the last box is going to have 45 Band-Aids in it. So that means I have 36 groups of 45. Now, instead of adding 45 together 36 times, which would take forever, what we're going to do is we then get the idea that it's repeated addition, which is multiplication. So I set up my problem, 45 times 36. You could also do 36 times 45. Remember, with multiplication, the order does not matter. So let's multiply out. 6 times 5 is 30. Drop the 0, carry the 3. 6 times 4 is 24, plus 3 is 27. Now I'm going to cross out this 3 because I used it. And I'm going to make sure I put my placeholder 0 in because now I'm multiplying by 30, not really 3. So 3 times 5 is 15. Drop the 5, carry the 1. 3 times 4 is 12, plus 1 is 13. Put that in, and I add my two pieces together. So that's 0. That's 12, carry the 1, 6, 1. So 1,620 Band-Aids. Again, just interpreting the problem, using a model to help us figure it out. Sample question number 2. Sasha had a $1,500 budget to order supplies for the office. If Sasha spent $768 so far, how much does Sasha have left to spend? So let's again go through the first sentence. Sasha had $1,500 to order supplies for the office. Now, I know when you're ordering supplies and you have a budget, that is the largest amount. You're not going to use an amount any larger than 1,500. So I'm going to call that my total, 1,500, and I'm just going to write it in green so you see where we got it from that first sentence. We know that Sasha spent $768 so far, and that $768 we know comes from the 1,500. Which means we are left to figure out how much she has left in the budget. So if I know one of the pieces and I know the total, that means I'm missing a part. So this is going to be a subtraction problem. So 1,500 minus 768. 0 minus 8, I can't do it. There's nothing to borrow, so I have to go to the 5, make that a 4. I can only pass it over once, so that's a 10. Now I can borrow from it, make it a 9. That 0 turns into a 10. 10 minus 8 is 2. 9 minus 6 is 3. 4 minus 7, I cannot do it. So 14 minus 7 is 7. So our answer is $732. So Sasha has $732 left to spend. All right, let's jump into sample question number 3. As you can see so far, these have only been one step. We will get into multi-step problems, but it is important for us to understand how we can draw different types of problems so that we can put that information together. So sample question 3, Charisse receives an annual salary of $47,760. If Charisse is paid monthly, how much will she receive each month? Notice we're not going to pay attention to taxes or anything like that, just a simple problem. So we know that Charisse receives an annual salary of $47,760. It doesn't say at all that she's getting any more, so we know that the total of the whole thing is $47,760. And I'm just going to model showing that that's the total. How do we know it's the total? Because you know how salaries work, that's the most amount you're going to get for that whole entire year. We're not going to end up with a number larger than that. If that's the annual salary, which means yearly, you know she has to receive less each month. So we're looking for either a subtraction problem to give us less or division. So we know that she's paid monthly. I don't see a number here, another number, so there must be a clue. Monthly, since there's 12 months in a year, we're splitting it into 12 pieces. So we know that the first month would be the same thing, the second month would be the same thing, the third month would be the same thing, all the way to the last month. So we're making 12 equal groups. Now remember, when we're making equal groups, each size is going to be the same amount. So what that means is that we're actually going to be splitting 47,760 into 12 groups. If you need to see how to divide by 2 digits, there is a great video that we have about how to divide whole numbers. So from here, we know 12 does not go into 4. 12 goes into 47. That's 3 times. 3 times 12 is 36. Subtract, we get 11, which gives us 7 here. We bring down our 7. I'm going to bring up the comma. So 117 divided by 12, that is going to be 9. 9 times 12 is 108. Subtract it. We get 9, and we bring down our 96. We know that 96 divided by 12 is going to be 8. 8 times 12 is 96. We subtract to get 0. Bring down our 0. Notice we're not done yet. We still have to use that last place value. 0 divided by 12 is 0. Minus 0. A lot of zeros at the end. But we know that she receives $3,980 each month. Sample question 4. In January, a hospital was able to treat 784 patients. That same hospital treated 1,288 patients in February. What is the total number of patients the hospital was able to treat in January and February? Okay, let's look. So we know that in January, a hospital was able to treat 784 patients. Now, I may not know what to do with that yet, so I'm just going to put that here. So I'm going to say 784. That same hospital was able to treat 1,288 patients in February. So if this is January, February has nothing to do with January, so that means I need a new box. And that means I'm going to put that box, oh my gosh, wrong way to set that up. So let's put that box here. And we know that February was 1,288. 288 patients, and that was February. So I have January next to February, and now I need to find the total amount. So what I'm missing is the total amount for these 2 months. How do I find the total of those two? I'm going to put them together. Now, the order, again, for addition does not matter. I just have a personal preference where I like to put the larger number on top. Just makes it easier to line things up for me. So 8 plus 4 is 12. Drop the 2, carry the 1. That's 16 plus 1 is 17. Drop the 7, carry the 1. This gives me 10. Drop the 0, carry the 1. So the hospital was able to treat 2,072 patients in January and February. I'm going to stop right here for real quick. If you notice, the first 4 problems we did here gave a model for each of our 4 operations. Problem 1 was a multiplication model. Problem 2 was a subtraction model. Problem 3 was a division problem model. And now we have our our addition model. So if visualization helps you, flag this video to check the first 4 sample questions in case you ever are unsure how to model, how to draw things out. All right, sample question 5. The average SUV gets 21 miles per gallon. If Cheryl is driving 798 miles across the country and her gas tank holds 14 gallons, how many times will Cheryl have to fill up her SUV's gas tank so she can make her destination? So if we look, we know that the average SUV gets 21 miles per gallon. So I'm just going to write that down. 21 miles per gallon. I also know that Cheryl, so there's nothing I can do here because there's only one problem. All right, there's only one number. Doesn't tell me anything else. If Cheryl is driving 798 miles across the country, I'm going to hold on right there. We know that the total is going to be 798 miles. So I also then need to figure out if her gas tank holds 14 gallons, how many times will Cheryl have to fill up her gas tank? So what we need to figure out is how many gallons of gas will Cheryl need to get across the country? Because then we can divide that by 14. So if we look, we know that she travels 798 miles. I'm actually going to move this over because we do need more space. 798 miles. And she gets 21 miles to the gallon. We're going to see how many are left. Now, when you're dividing this here, and I'll show you. So this is miles per gallon. When you end up dividing here, if they have the same units, like this is miles to miles, those units will cancel out and they'll tell you what you're left with. So at the end, we'll be left with gallons. So that is also a good indicator if you're unsure of what to do and what to cancel out. That's where you can look. So let's do the actual division. 21 does not go into 7. 21 does go into 79. That's 3 times. So 3 times 1 is 3. 3 times 2 is 6. That's 63. And I'm left with 168. That is going to be 8 times. 8 times 1 is 8. 8 times 2 is 16. We subtract and we get 0. So what does this mean? We see here that we were left with gallons at the end. So that means that our units must actually be gallons. So we think 38 gallons. 38 gallons to do what? That's 38 gallons of gas that she needs to travel across the country. So now we can take that she holds 14 gallons in her gas tank. And we need 38. So if we think about this, if the whole trip takes 38 gallons, let me use G for gallons, I know that after 14 gallons are used, I have to stop. 14 gallons are used, I have to stop. So I'm really making equal groups of 14. So from here, I can actually do our division. So we have 38 divided by 14, and if we look, so that's 0, that's 2, because 2 times 14 is 28. We're left with 10. So we have 2, remainder 10. Now, remember, those 10 gallons are not going to be able to come out of nowhere. She does need them. So, in this case, she will have to stop 3 times. So we are going to count that first time she fills up is that first 14. The second time she fills up, that's another 14. That takes us to 28 gallons, and she does need to stop then a third time for those last 3 gallons. These are the trickiest problems where decimals do not make sense, because you could not have stopped a remainder of 10 times. You could not have stopped 5/7 of a time at a gas station. You need to make sure you stop there the whole time. So that officially counts. All right, here comes our last sample question of this lesson. We have Larissa spends $1,250 on rent, $112 on electrical, $86 on water, and $215 on cable. If she received $1,867 this paycheck, how much will she have left over after paying her bills? So we can look at this a few ways. So we know that she has some expenses. And sometimes you can change the order if you really need to. But one thing that really got my mind, and this is why we read a problem first, is that I know that she receives $1,867 in total. That's for the whole thing. Everything else comes from her paycheck. So $1,250 on rent comes out of it. We know that $112 on electrical, we know $86 on water, and $215 on cable. And then whatever's left would add up to $1,867. So we can do this a few ways, because this is going to be a 2-step problem. So our first step, and the first step I'm going to take here, so we did this, we looked at our bills here, and we want to know how much is left. So instead, I'm going to first add up all of her bills. You could change the order as much as you want to. You could have done 2 numbers at a time, then add the third, then add the fourth. However you do it, as long as the addition is there. So that's 8, that's 13, carry the 1, 6, 7, 8, that's going to be 16. That's 3, 4, 5, 6. So we know that she spent $1,663. But we're not looking for how much she spent. We're looking for how much she will have left. So she makes $1,867, and she spends $1,663. Based on what I know about buying things, budgets, how much money you have, and spending, I know that it's going to be a subtraction problem. So 7 minus 3 is 4, 6 minus 6 is 0, 8 minus 6 is 2. So we know that she has $204 left. All right, it is now your turn to practice, to try these out, to go to the quiz and see what methods work best for you. I cannot wait to see you in the future. I hope this helps, and I look forward to working with you soon. Good luck.
Y'all, that was wild, but congratulations on crushing another lesson here at Nurse Hub. You should be proud, and then continue working to make sure you fully understand everything that you just watched. Remember, practice is the only thing that we need to make ourselves better at all of these topics. Good luck, and I hope to see you soon.